What if the world's most advanced AI models are acing their medical exams, not by understanding medicine, but by learning how to cheat the test? There's a really great, interesting paper just out by Microsoft Research suggesting that this is exactly what's happening, creating what they call an illusion of readiness. And it reveals that models are learning to be brilliant test takers, not brilliant doctors, by finding clever shortcuts to the right answers. This isn't about minor glitches, it exposes a fundamental flaw in how we measure progress in health AI. So how did the researchers catch these models out? They designed a series of ingenious stress tests to probe for weaknesses hidden by impressive leaderboard scores. So I'll give a few examples of the specifics of what they did. So first they tested what happens when you remove the image from a question that requires both text and a picture, like an X-ray. On one benchmark, GPT-5's accuracy dropped by over 13 percentage points. But even more telling was a test on questions where clinicians agreed that the image was essential for diagnosis. Here, the models still scored far above random chance. So again, GPT-5 got nearly 38% right with no image at all, which is significantly higher than the 20% that you'd expect by random chance. This proved that they were relying on subtle, non-visual clues within the text to make their answers. Next, they attacked the format of the test itself. Simply shuffling the order of multiple choice answers caused a significant drop in accuracy when models only had the text, showing that they were learning positional patterns in the answers rather than the medical content. But arguably the most powerful test was visual substitution. So researchers took a question but swapped the image for one that supported a different, incorrect answer choice. A model with a genuine understanding should change its answer to match the new image. Instead, performance collapsed. Top models saw their accuracy plummet by over 30 percentage points. This was a bit of a smoking gun. It showed that the models weren't truly integrating text and vision, but were relying on brittle, memorized associations. Finally, when asked to explain their reasoning, the models often produced convincing yet flawed justifications, sometimes confidently describing visual features of an image that weren't even there. This is a really crucial constructive reality check. It isn't a reason to abandon AI, but a clear call to get much smarter about how we validate it. This is where the researchers outline a clear path forward, and it's all about rethinking our relationship with benchmarks. First, we have to stop treating benchmarks as the final exam and start using them like a diagnostic tool. Their purpose shouldn't be to generate a single winning score, but to reveal a model's specific capabilities and, more importantly, its likely failure modes. Second, this means that we need to move beyond a single leaderboard score. A model's performance should be broken down along medically meaningful lines. We need to know how it performs on visually complex tasks versus text-heavy ones, not just see one simplistic blended average with a single number. And third, we need to ensure that the test matches the job. Evaluating a generalist AI on a benchmark that's mostly text solvable tells you nothing about its readiness for a real-world radiology task that is intentionally visual. In medicine, trust is built on evidence, and the evidence from this paper is clear that benchmark leaderboards on their own are not a reliable signal of real-world readiness. They create a dangerous illusion of competence. Real medical readiness isn't just about accuracy, it's about being reliable, interpretable, and safe when faced with the messy, uncertain data of real patients. The fact that models can fabricate plausible but incorrect reasoning is a major barrier to trust. So what's the big takeaway here? These aren't necessarily new ideas, but it's a really elegant demonstration of how the problem applies to medicine and how we can start to think about revealing this kind of overfitting to the test benchmarks. The research calls for a fundamental shift in our mindsets and our standards. The path forward requires 3 key actions, I'd say. So first, we need to demand that evaluation protocols routinely include these kinds of adversarial stress tests, reported right alongside standard accuracy metrics. When a vendor presents a new dazzling score, our first question shouldn't necessarily be how high was the score, but how did you try to break it and in what circumstances did it or didn't it break? Second, we need to treat benchmarks as a tool for assessment, not as targets for optimization. Their role is to reveal models' limitations under realistic conditions, not be gamed at the cost of real-world generalizability. It's a perfect example of Goodhart's law, that when a measure becomes a target, it ceases to be a good measure. And finally, we must match the evaluation to the deployment context. This methodological, stress test-driven approach is how we must move past this illusion of readiness and start building AI that's genuinely ready for the reality of clinical practice.